So since the number of sequencing cycles is limited to a maximum of 300, and even that is typically not done, you will get short reads. So the shortest Illumina reads that I have worked with are 36 bases long. That's really short, but it works. It's okay. For some applications, that's enough. And well, the longest is around 100, 150 bases. Why short reads? There are some disadvantages with short reads. At some point during the analysis, you have to align your reads to the genome sequence. The shorter they are, the harder it will be to align them, because the more locations they can align. So there are disadvantages to short reads. So why is Illumina generating them? Well, there are two reasons for that. And the first one has to do with overlapping clusters. You have already seen that this is something that you don't want, because then the base calls will be very hard. You will get mixed signals. You will get base calls with very low qualities. So they want to avoid that as much as possible. So this is one reason why they work with short fragments. Yeah, I told you, you do a size selection of your fragments between 100 and 800 base pairs. And the reason for that is that during the amplification, I'm going to go back a bit. Here, when bridges are formed, you want to have small bridges. The longer your fragments, the wider these bridges can become, but also the wider your clusters will become. And if you have very wide clusters, you have a higher risk that they will start overlapping. So Illumina wants compact and dense clusters. That gives the best signals. So this is why they want to work with short fragments. Why do you generate such small reads from these fragments? Because your fragments are longer than your reads. Typically, you don't sequence the full fragment length, but just a part of your fragment. So why? Why short reads? Well, because the longer you sequence, the more the quality drops for the entire sequencing for all the clusters. And at some point, the quality drops so much that it's not worthwhile to invest more time and money in the sequencing. And this is also a reason why they typically stop after 100 or 150 bases. I will come back on this quality drop later. I will explain why it drops, but I'm not going to do it yet now. So you typically end up with short reads, and for most applications you see this size range, 50 to 75 base pairs. That's cheap, so the more sequencing you do, the more money you have to spend. And that's also enough. So if you want to do applications like RNA-seq, you're interested in differential expression, or for applications like ChIP-seq, short reads are fine. You don't need long reads. And it's better to spend your money on doing paired end sequencing, I will come back on that, or on sequencing more samples, than to spend your money on generating longer reads. The only applications for which it's really a good idea to have long reads is when you want to look at variations. If you want to look at large deletions or large insertions, large mutations, you need long reads. You will not find them with Illumina. If you want to do assembly, it's a better idea to invest money in long reads, because it will be much easier to assemble long reads than to assemble very short reads. Now, to cut the costs for assembly, they often do a combination of long and short reads. That also works. But for all other applications, there's nothing wrong with short reads of only 50 base pairs.